This segment we're going to look at radical signs and converting them back to exponents. For example, the fourth root of n can be written as n to the 1/4. Now a lot of times, especially in the last segment, I've had you look at n to the 1/4 and think of it as the fourth root of n. Well, there are some benefits when you can actually take roots and change them back to exponents. For instance, if you happen to have, let's say, the fifth root of x to the 5, y to the 10th, and z to the 12th. If I would look at each piece and say, okay, this is x to the 5th, y to the 10th, z to the 12th, and raise it all to the 1/5, then I can also look at this as x to the 5/5, y to the 10/5, z to the 12/5, and realize that this is actually x to the 1st, y to the 2nd, and z would still be to the 12/5, but even that's going to be useful in a moment because anything that's a whole number can actually be pulled out of the radical. So I could actually have an x on the outside, I could have a y squared on the outside of the radical, and since 12/5 is actually 2 with the remainder of 2, I can actually have z pulled out with a square on the outside and then have a fifth root of z squared on the inside. Now, it all depends on what I'm asking. Sometimes they just ask you to write it without a radical sign. If that's the case, I would like this as an answer. Sometimes if I ask you to please simplify a radical, well then this would be a better approach. Either way, it does help to understand that nth roots can be written as exponents, and you can use as follows. For instance, if I actually have the 7th root of a 6th root of, let's say, x to the 5th, what I would do is I would look at the innermost piece first and write that as x to the 5th and raise that whole thing to the 1/6. Well, that means I'm actually looking at the 7th root of x to the 5/6. Well, if I then decide to rewrite the 7th root as 1/7, I would then realize that I can multiply these exponents together and come up with 5/42. So actuality, this crazy problem is nothing more than the 42nd root of x to the 5th. Now again, do I want a radical? If I do, this would be its simplified form. If I just want the exponent, this would be the answer. If for some reason I had the 4th root of a cube root of AB, I am allowed to go the 4th root of AB quantity raised to the 3rd. And I'm allowed to go the 4th root of technically A to the 3rd, B to the 3rd. Now, I may wait and hold off on that. I may have chosen to do this instead. I may have chosen to say AB to the 1/3, raise it to the 1/4, come up with AB quantity raised to the 1/12, which would have been no different if I would have said A to the 1/3 raised to the 1/4, or B to the 1/3 raised to the 1/4. In either situation, I am allowed to say A is raised to the 1/12, B is raised to the 1/12, or simply say the 12th root of the quantity AB. You can break them up as individual pieces, A to the 12th, B to the 1/12, or you can say the 12th root of AB. On the other hand, if I had said the 4th root of the cube root of the quantity A plus B, again, this is an addition problem inside. You will not be allowed to do exactly what we did. You may still write A plus B to the 1/3, but you are not allowed to go A to the 1/3 plus B to the 1/3. There has been no rule that has taught you that. So don't do any of that kind of stuff and focus on just simply saying, I'll take A plus B, raise it to the 1/3, raise that to the 1/4, come up with A plus B to the 1/12, or simply say the 12th root of A plus B. Just do not know A to the or 12th root of A plus 12th root of B, or A to the 1/12 plus B to the 1/12. This is all just very, very bad. If you have A to the 1/6, you may think of that as the 6th root of A. If you would have to have B, let's say, to the 3/7, you can look at it two ways. You can think of it as the 7th root of B, and that is all cubed, and because you could have broken it up as B to the 1/7 and then raise that to the 3, because 1/7 times 3 is 3/7, and therefore you can look at it like that. But if you choose, you could have thought of it as the 7th root of B cubed. I don't really have an issue with either one, because B cubed could have been done first, then raised to the 1/7. You're still multiplying 3 times 1/7, getting 3/7, and that could be an answer as well. Bigger concern is when you start mixing variables, let's say C to the 2/5, and oops, a little error, and let's say D to the 3/5. Well, the nice thing is they are both raised to the 5th. So if you wanted to say C squared D cubed raised to the 1/5, you're allowed to say the 5th root of C squared D cubed. If for some reason E would be raised to the 3/4, and F would be raised to the, let's say, 6/7, my suggestion is you would want to have a common denominator for both of the fractions first. So since both of them could be the same as 28, then I would just have to realize that 3/4 is the same as 21/28, and F would be actually raised to the 24/28. Therefore, I could look at this as the 28th root, because they both have 28 as the denominator for their exponent, and that would be E to the 21st, F to the 24th. Finally, if you start getting into negative exponents, for example, you have G, let's say, to the negative 2/3, and you have H raised to the positive 1/3, you could look at it as the cube root of G to the negative 2, H to the 1st, and honestly I would never even write the H raised to the 1. But the key part is, because of the negative exponent, I think you'd be better off looking at it as the cube root of H over G squared. Now you could have done that immediately back here if you would have thought of, going like G to the negative 2, H to the 1, raise that to the 1/3, and then write that immediately as H over G squared raised to the 1/3, and you would have gone back to this result. J 7/11, and you have K raised to the negative 4/5. I would definitely have a common denominator first, in this case 55, and let's see, that would be 35/55, and K would then be, let's say, negative 44/55. Just remember that the K is going to be in the denominator, so I'm going to draw that right away. The K would move down here, say to the 44th. J would stay up to the 35th, and then that would all be the 55th root of that particular problem.